Okay, this will be a pre-class assignment for lesson 104 for triangle similarity. And what we're going to cover today is 4 theorems, just as an introduction before class. So our first theorem is the triangle proportionality theorem. And it states that if a line is parallel to one side of a triangle and intersects the other two sides in two distinct points, then it separates these sides into segments of proportional lengths. Okay, so this is what it's talking about. We've got triangle ACE, the outside triangle. Inside of that triangle, there is a segment that intersects two sides of the triangle, and that's the segment BD. Because BD is parallel to another side of the triangle, then it separates the sides it's connected to into proportional sides. And what it's stating here is that it separates this whole side here into proportional sides, and the same with the one above. These will be proportional. And kind of what you need to look for is if we are giving a length of 4, then this side here would have a length maybe of 8. So it's proportional. And then the same would be true for the opposite side. This could be, say, 6. This would be 12. So they're both like double. Now the proportion itself will be different every time, but it's telling you that the two parallel lines and the intersection create proportional sides. Now, the next one is the converse of that. Now, the converse triangle proportionality theorem states that if a line intersects two sides of a triangle and separates the sides into corresponding segments of proportional length, then the line is parallel to the third side. What they're saying here is if we have a line, say BD, and BD divides up this triangle so that again we have proportional sides. So let's say this time it's 2 and 6 and 3 and 9. Since those are all proportional, then we can conclude that this last side is parallel to the segment BD. So just to kind of rehash that, if two segments are parallel, then the sides will be proportionate. If the sides are proportionate, then the two segments will be parallel. Alright, the third theorem is the angle bisector theorem. And this states that an angle bisector in a triangle separates opposite sides into segments that have the same ratio as the other two sides. Okay, so a couple things. First, an angle bisector. That means that segment AD is bisecting this angle into two equal parts. Okay? What it's creating then is a ratio where the two divided triangles, the two triangles that are created from the divide, will be the same ratio. That would be like saying 12 and 6 and 8 and 4. They both have a ratio of 2. Now, the converse to the angle bisector theorem states that if a point separates the side of a triangle into segments that have the same ratio as the other two sides, then the line segment from the opposite vertex to the point bisects the angle. This time what they're telling you is that since these are going to be the same ratio, so again, say 12 and 6 and 8 and 4, because they have the same ratio, then AD is bisecting angle A. Good gracious. I'll try that again. Alright, so this is just an introduction of those four theorems, and then in class we will work with them, and usually it gets a little more clear once you start working with it.